can't put up videos. I can't put up the videos, ladies. I can't put up videos for the lessons, and then if it ever came down to it, for the relearn packet, which would be a horrible thing. So I need to do some work with this. Okay. You know, we've been building a base all year long, a base on which to learn, and now we're starting to funnel that base toward the Regents exam a little bit and the kind of questions that are going to be asked. Every single question on this quiz is a typical Regents question. Some of them I actually just changed the numbers for, and some of them I'm going off of years' experience in terms of the Regents exam. And what I was really encouraged about is there were a good number of hundreds. Raise your hand if you got 100. Up high, please. 2, 4, 6, 7 hundreds. And the people, even if you got a 50, it wasn't like it was, oh my God, I'm clueless, I got it completely wrong. It was stupid things like, for instance, leaving the little line off the bottom of the inequality, Maggie, or leaving the x out of the equation, Mary. It was tiny little things that these questions on a Regents exam would be multiple choices, and they would have an x in every choice. They would have had the or equal to symbol. So I don't think you would make those mistakes on the Regents. So clean them up a little bit. We'll get you ready to go. I was very encouraged by the quiz. I thought that we did a great job. And for those who didn't get the 100 yet, I feel bad that you didn't get a pudding, but you will have your opportunity to get something.
When we run out of pudding, you need to get more.
I'm getting the idea that that's kind of a command.
No, it's a question.
You think it's gross?
Yeah.
I'll tell you what I would have a hard time
Can
resisting.
you get like the vanilla?
Well, I was just going to tell you, if I found the vanilla, I don't think I could say no, because I love vanilla pudding.
I like both.
All right. Let's just say that I try to find creative ways to motivate. So if it's one flavor pudding versus another, I will do my best. All right. What's the slope of the line? It works out to be a half. If you did not get the slope correct, check with another person around you in a little while. It's really pretty straightforward. I do, however, want to talk about number 2 because that's a whole lot harder. Are you guys with me here? No. Hey, excuse me. Do you know what you're teaching me right now? Well, that's what happens when I say let's get to work and all I hear is irrelevant. Now, I want to make sure we know how to do this particular question here. One reason I'm not going over the slope question in number 1 is we're going to do a slope question right now. So you would do it the same way. The big thing is to set up your equation, the y from the second point minus the y from the first over the x from the second minus the x from the first. So there's my setup, 9 minus 5, because the y from the second is 9, the y from the first is 5. The x from the second is 3, the x from the first is 1. So 9 minus 5 is 4, and 3 minus 1 is 2. Jaden, if you look at your paper, the other day, I think, if I remember right, I'm not positive, I think the other day you mixed your x's and y's. When you did that, did you get 4 over 2 for the first part of question number 2? Good. All right. And that reduces, obviously, to 2. But that still doesn't answer the question. I know one person on their answer, they wrote y equals 2x plus b. And that is a true statement, but it's not the answer to the question. It wants the whole equation to the line. So now I am at the point where I can say y equals 2x plus b. And the whole thing you have to remember at this point is if you had an x and a y, you could figure out b. God bless. And they don't say to you x is and y is, bless you. Instead, you have to surmise what x and y are. So I can use either one. I'll use this one just because it's closer to me. The x is 3 and y is 9. That's an xy pair, input-output pair. So 9 equals 2 times 3 plus b. 9 equals 6 plus b. Subtracting 6 from both sides, b is 3. And it wouldn't matter if you used the other pair. You would also get that b is 3. So my final answer is y equals 2x plus 3. I take the 3 there and plug it in. And that's my answer. Okay, I think that's a pretty challenging question, yet we had a lot of people get it right on the quiz, which was very encouraging. Any questions? Okay, number 3 talks about Jaden starts a record business, right? Yeah, okay. She sells songs in an MP3 format to people and charges 75 cents per song. To do this, she uses a website that costs her $375 to publish and maintain. Write a function for the profit, where X is the number of songs sold. So the profit, each song makes her 75 cents. So it's going to equal 0.75 times the number of songs she sells. But you have to subtract 375 that it costs her to get started. So there's the profit of X formula, okay? And last but not least, the trout per mile. Now, I saw some scrap work on people's papers, and I think the biggest thing that people struggled with was how to express the answer. And I go back to the phrase in the question, compound inequality. Look, they average, their estimate is 4,000 trout per mile, but they're saying that there is a factor of 200 trout where it could be plus or minus 200 trout per mile. So if it was minus, it could be 3,800 trout in a mile. And if it was plus, it could be 4,200 trout in a mile. So those are my boundaries, if you will, for the bounded interval, 3,800 to 4,200. And the number of trout can be anywhere in between them. So this is my compound inequality. 3,800 is less than or equal to the number of trout, or X, or N, don't care what the variable is, which is less than or equal to 4,200. Okay? Preguntas? Any questions? Yes?
Why do the thingamajiggers have to go that way?
Okay. You have to be bigger than the 3,800. That's why the T is on this side, because it points to the smaller number. But you also have to be less than the 4,200. If I wrote it the other way, then that would be saying that the number is greater than or equal to 4,200, but the number is also less than or equal to 3,800. What numbers are less than 3,800 but greater than 4,200? There are no such numbers, so I can't write it like that.
Okay.
Good question. Anything else? All right. All right, so now a little a review question here. Here's an example of why it's so great when you get a few Regents exams under your belt. The Regents exam has now had 5 editions made. At the end of January, there'll be a 6th Regents exam test, and I have chopped up every Regents exam and divided them by subject areas. So on the practice set of exercises the state gave us way back when we switched over, and they only gave us a handful of questions. 2 of them were rate of change questions. And then, on the very first test, there was a rate of change question, and on the second test, there was a rate of change question. So I'm thinking, rate of change is a really important topic that they're gonna test all the time. And it hasn't been on the last couple of tests too much. So I don't know if that means, uh-oh, they're really gonna put it on the next test, or maybe it's not so important. But one way or another, we gotta make sure we are prepared for it. Now, what's a rate of change really mean? Slope, good. So we go back to the slope formula, y from the second point minus y from the first, over x from the second minus x from the first. And then you look at this and you say, but wait a minute, I don't have any points. So you have to find the points. And this is really the difference between algebra and 8th grade math. You need to find the points. It's over the interval. These are bounded intervals, so x is -2 and it is 3. So if I plug in a -2, I'm going to get 4 plus 6 is 10. And then if I plug in a 3, I'm going to get 9 minus 9 is 0. So now I have my 2 points, -2, 10, and 3, 0. Is there any question about how I got those points? Okay, now, I'll call this point 1 and this point 2. I don't care which is which. The y from the second is 0, minus the y from the first is 10. The x from the second is 3, minus the x from the first is -2. Then I get -10 over 5, which is -2. Okay? Any questions? All right, -2 is the correct answer. Now, the next part kind of leads into some work that we'll be doing over the next few days, graphing an inequality. Now, Graphing an inequality is a lot like graphing a line. I'm just going to go through this, and then I'm going to point out the subtle differences. The slope is 2, the y-intercept is -5. So I go to -5, 1, 2, 3, 4, 5, up 2 over 1. Am I doing anything different now?
No.
No. So far, everything looks the same. There are two primary differences between an inequality and an equation. The first one is this. When you graph an inequality, the line itself can be broken or solid. In this case, it's broken line. Now, the question is, why is this a broken line? And the answer is pretty easy. You know how if I was to graph n is greater than 5 versus n is greater than or equal to 5 on a number line? Put 5 there. In this case, you're going to fill the circle in. And in this case, what are you going to do? You're going to leave it open, right? So when there's no or equal to underneath, you don't fill the circle in. So think of it as when there's no or equal to, you don't fill the line in. Okay? Same exact idea, same concept. What's that?
You don't fill the line in?
Think of it that way. If you look at it, it's kind of like you're doing a line. It's clearly a line there, but it's not a solid line. Just like this is not a solid circle. Whereas when it's allowed to be equal to, it's a solid circle.
How do you know? What would it look like if it's?
Well, if I put an or equal to line underneath, I would just use a solid line. It would be a regular line. Okay, what's that?
How do you know the y is less than 2?
Well, slow down. You understand the -5, the up 2 over 1, right? So the only new thing, God bless, the only new thing that you're supposed to get out of this so far is that if it's less than or if it's greater than, the line is always a broken line. That's the first thing you're supposed to get. If it's less than or equal to or greater than or equal to, then it's a solid line.
Oh, I see.
Okay.
When I said it was bad, I thought it was a broken line.
No. So that's the first thing. Are we clear on the first thing you're supposed to understand? Now, the next thing you have to understand is this. When you graph a line, it's a picture of all of the points that check in the line. We went over that the other day. When you graph an inequality, it's more than just the line. Just like when you solve an inequality. For example, if I do a regular inequality like 3x minus 1 is less than 8, I'm going to get x is less than 3. Now, 3 is not an answer, but 2 is, 1 is, 1.5 is, -99 is, -1 billion is. There's an infinite number of answers to this one because it's an inequality. Likewise, there are an infinite number of answers here. You're going to have to show all of those answers. Just like we shade the number line to show answers here, now we're going to shade the graph. And the question is, are we going to shade above the line we just drew, or are we going to shade below the line we just drew? Now, is this a less than symbol or a greater than symbol? So what side do you think you shade if it's less than? Less than would be above. Doesn't above give you the sense of being more than or greater than? Yes, therefore I shade below.
You just said above.
Oh, did you say below? I hear horribly. I thought you said above.
No, I said below and you said above. And then
Okay, yeah, that's because I had thought you said above. All right, so anyway, there's my graph. So those are the two big differences between graphing a line and graphing an inequality. The similarities do the same exact thing. Slope, line, intercept. Graph them, bang them out. Then you got to look for two things. The first thing you got to look for, is it broken or is it solid? Second thing, do you shade above or below? And that's all you need to know about inequality. All right? Questions? All right, so now, what was that? All right, now let's go to the next idea. We just went into the two different possibilities here. Now, here is an old Regents exam question from, I think, 2 years ago. It's a very popular Regents exam type question. They love to put on there. Now, let's graph the first one. Y is greater than or equal to 3x minus 4. Only graph that one. Do not do the second one yet. I want to do that one with you. Graph the first one. You got about a minute. I'll put it up on the board when you're done. Remember, broken or solid. You've done right. Broken or solid, and shade above or below.
what do you like? Say that.
Okay, so for this particular problem, the slope is 3, the y-intercept is -4, so I begin at -4, I go up 3 over 1, and now I ask the two most important questions about this problem. Is this a broken line or a solid line? Solid, because it's or equal to, so I connect the dot this way. And now, do I shade above or below? Above, because it's greater than. So, there's my graph. Okay? Now, typically when they ask this on the Regents exam, they will give you one line that's in standard format, like this one. And then they will give you one line that you have to manipulate. So now we have to go left. -2y plus x is greater than -4. 2y plus x, okay. What do I think the first step is?
To get y by itself.
Yes, and what specifically would you do first?
Subtract.
Subtract the x, good. So I subtract the x, and I get -2y is greater than -x minus 4. Die there. Okay, what do I do next?
Wait, why you went minus x? -2 minus x.
You could, that would be fine. It's the same exact thing. The reason I write it this way, Emma, is I'm so used to mx plus b that I want to put the x part first. But if you were aware that the slope is what's in front of the x and you put the x second, it wouldn't make any difference. All right, any other questions? All right, so what do I need to do next? And this is a danger moment. Because when I have an inequality and I divide by a negative, what do I need to remember to do? Flip that symbol. So greater than becomes less than 1/2 x plus 2. Okay? So what's my slope? 1/2. And what's my y-intercept? 2. So I begin at 2, and then I go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and I keep that pattern going. Fill it in the backside. Now earlier on I used to tell you with lines that make sure that when you graph them, oh, is this broken or solid?
Broken.
Broken. When you graph them, make sure you extend them over the whole distance. Whoa. And the reason it's so important is because you have to find where they're going to intersect, or in this case, where they're going to overlap. So the first difference is that it's a broken line. The second one is, do I shade above or below? I shade below because it's less than. So I come down here. All right, so I'll let you catch up on that, and then I will do some explaining to you. Now, anytime that I have students graph inequalities, or the students are asked by the state or whatever, I always make it a habit of wherever it's double shaded, I write a great big S. Now, bless you, what am I getting at with that? This is what I'm saying. I'm saying, look, for the red inequality, everything in the shaded region is a point that checks in the inequality. For instance, the point 0, 0 is in the shaded area for the red. Is it true that 0 is greater than or equal to 3 times 0 minus 4? Yes, definitely. 0 is greater than -4, so it belongs in that shaded area. Let's see the points that check. And by the way, if I pick a point over here, like 100, 0, then, wait, where's the, I'm looking at the red line here. Let's say I picked a point like 100, 0. That's way over here. It's not being shaded in. Is 0 greater than or equal to 3 times 100 minus 4? No. So it's not shaded. Only the shaded area are the points that would check. Same thing for the blue inequality. Now let's check the point 0, 0, again in the blue one. Is -2 times 0 plus 0 greater than -4? Yes, absolutely. So therefore, it should be shaded too. Now, this area of the graph that has both red and blue shading is the area of the graph that checks in both inequalities. So anything in there is what we would call the solution set. And the great big green S stands for solution. Oftentimes, when you do a question like this, they will complete the question by saying, choose a point in the solution set. So, you label a great big S, and then I always look for the point 0, 0, because it's so easy to use, and then I could always check it. If they said justify your answer, you could say, well, it's in the double shaded area, or you could check it and show that it works in both points. Okay? Any questions? Okay. I believe it's time for you to start your,
Homework.
yeah.
Yeah.
Graphing is a lot of work. Just do it, just graph and do it. Do you want me to throw those away again? What's that? Knowing I hear poorly, couldn't you pump up the volume a little bit? There we go. Nice.
If it's a negative,
Yes.
would it be a negative for both?
What is it?
Just blow.
Oh, if the slope is negative, it's down one to, down however many to the right, down to the right. We always go left to right. Positive goes up, negative goes down.
How do you, how would you express something if it's both negative?
Then I would do a negative divided by a negative is a positive, and I would go up.
So you can't.
Logic.
If you did, it would still work, but it gets confusing, so I avoid it.